Welcome to BSc Statistics students. In this class, I explain one of the growth curve, modified exponential curve, fitting of modified exponential curve in the method of partial sums. This is the one more method, second method. We have already discussed the method of three selected points. In this class, I explain in the method of partial sums, how the modified exponential curve is going to be fitted. So first of all, I write what is the modified exponential curve. The yt is equal to a plus b into c power t. This is what the modified exponential curve. Okay. So I consider this is equation 1. So what is the method of partial sums? By using the method of partial sums, how can the modified exponential curve is going to be fitted? What we do is we divide the entire time series data into three particular equal parts, corresponding to the values of yt. We have to divide the corresponding to values of the time periods. The values of yt, that is of the time series data, it is going to be divided corresponding to the time periods t into three equal parts. How? For example, first n consecutive values, that is of the values of the yt corresponding to the time periods t is equal to, for example, 1, 2 and so on n. This is first particular part. The second part, t is equal to n plus 1 corresponding to that is value of yt corresponding to the t is equal to n plus 1, n plus 2 and so on 2n. This is second part. The third part, t is equal to 2n plus 1, 2n plus 2 and so on 3n. This is the third part. The three particular equal parts. This is one, the second one, the third one. According to these time periods, respective to this particular time period, corresponding to these time periods, the values of yt is going to be considered. This is the values of yt corresponding to these n points, time periods. The yt value of yt is going to be considered as the first part. The second part, corresponding to n plus 1 to 2n time periods, the value of yt, it is going to be considered here. And similarly, 2n plus 1 to 3n time periods, corresponding to 2n plus 1 to 3n time periods, the values of yt is going to be considered in this particular part. So three parts, 1, 2 and 3. Three particular parts, the values of the time series data is divided into three particular parts corresponding to the time intervals, time periods, right? So we consider the partial sums of the time series, the partial sums of the time series, of the values of the time series at the three particular parts. Let it be S1, S2 and S3. So that is what the modified exponential curve yt, the values of yt is going to be considered. The sum of all yt is S1, sum of all yt S2 in the second time period, and sum of all the values of yt in the yt is going to be considered in the time period, third time period, that is S3, right? So now by considering yt is equal to a plus b into c power t as the modified exponential curve, the S1 becomes, now I am calculating S1. What is S1? S1 is nothing but, first of all, I'll tell you first of all S1. S1 is nothing but summation t is equal to 1 to n yt, that is S1, and S2 is equal to summation t is equal to n plus 1 to 2n yt. What is S3? S3 is equal to summation 2n plus 1 2n plus 1 to 3n yt. So these are the three particular values. S1 partial sums, that is partial sum of the S1. S1 is nothing but sum of all the time periods of yt at the time period t is equal to 1 to n, that is these are the time periods, t is equal to 1 to n. N plus 1 to 2n, if you do the sum of the values of the yt, it is nothing but S2. S2 is equal to summation t is equal to n plus 1 to 2n yt. And S3 is equal to summation 2n plus 1 to 3n yt. Hope you understand. Now we are calculating the modified exponential curve by using the modified exponential curve S1. S1 is equal to summation t is equal to 1 to n yt. Yt is summation t is equal to 1 to n. Yt is a plus b into c power t. So summation of a constant t is equal to 1 to n terms. Therefore na plus is a constant a, and with respect to summation. And b we can outside here, take it outside. This is nothing but b into summation c power t. So we are writing b into summation c power t. N is equal, t is equal to 1 to n. Hence it is na plus b into summation t is equal to 1 to n c power t. Is nothing but substitute c is equal to t is equal to 1. That is c. C is equal to 2 c square plus and so on, plus c is equal to n c power n. You understand this, right? It's a simple part of the taking the summation. Na plus b into, again I am taking a common as c, hence it is, then it becomes 1 plus c plus and so on plus c power n minus 1. Hence this is in geometric progression. Therefore we can calculate na plus b into c, bc into some of the terms in the geometric progression, some of the n terms, which will be c power n minus 1 divided by r, that is a power r minus 1 divided by r minus 1. R is c by 1, the term c square by c, again c, like that. So therefore it is geometric progression, c power n minus 1 divided by c minus 1, the total of these terms. So therefore this is S1. So S1 is nothing but it is Na plus Bc into c power n minus 1 by c minus 1. Similarly, we can also write, we can also calculate S2, partial sum of S2. S2 is nothing but summation t is equal to n plus 1 to 2n yt, which can be similarly, simply we can write as it is Na plus b into c power n plus 1 multiplied by again c power n minus 1 divided by c minus 1. And similarly, now you can write S3. Hope you understand. This is Na plus b into c power 2n plus 1 multiplied by c power n minus 1 divided by c minus 1. So these are the terms we have calculated, S1, S2, S3. So I am considering S1 as equation 2, S2 equation 3, S4, S3 equation 4. Equation 1 is yt is equal to a plus b into c power t, the modified exponential curve. So for which we have calculated three partial sums, S1, S2 and S3. Three partial sums, S1, S2, S3. Which are these? These are the values. Now what do we calculate? We subtract S2 and S1 so that we will get S2 minus S1, and also we subtract S3 and S2 so that we calculate S2 minus S1, S3 minus S2. So first of all, S2 minus S1, we subtract S2 minus S1. So we can easily observe here Na, the term here, Na the term here, Na minus Na becomes 0, and b into c power, b into c, if you take a common, bc multiplied by and also you take a common c power n minus 1 divided by c minus 1 multiplied by, here we have c power n multiplied by, and if you take a common, then here we have a c power n because we have taken common as b c power 1, that is c power n minus 1 by c minus 1. Then you have only c power n here. Here it is 1 minus 1. So therefore, this is the term, it is equivalent to be bc into c power n minus 1, c power n minus 1. So c power n minus 1 whole square divided by c minus 1. You understand? This is what? S2 minus S1. S2 minus S1. BC into c power n minus 1 whole square divided by c minus 1. Let us consider this is one more equation. Let it be 5. One more result. One more equation. And now, subtracting S3 and S2, what you will get? That is from the 3 and 4. From 3 and 4, subtracting 4 and 3, 4 minus 3, what you will get? That results S3 minus S2. That is what we are calculating, S3 minus S2. Again, if you refer here, NA minus NA, these two terms will get cancelled, and now the term which is common here, BC into B into C power n plus 1, here 2n plus 1. Therefore, we can take n plus 1 as a common. And then c power n minus 1 by c minus 1, this is also a common. So, B into c power n plus 1 multiplied by c power n minus 1 divided by c minus 1 multiplied by c power n minus 1 by c minus 1. If you take common, then in this particular term, that is in the second term, the first term S3, in equation 4, you will have, if you take common b into c power n plus 1 divided by c power n minus 1 by c minus 1. Then here c power n, we have taken already one particular n common. So therefore c power n. And here the term 1, only 1, because we have taken entire term as a common. So therefore c power n minus 1. Do you understand this? So what you will have the term only here c power n, here minus 1. So therefore c power n minus 1, c power n minus 1, it becomes whole square. Therefore it is nothing but now b into c power n plus 1 into c power n minus 1 the whole square divided by c minus 1. So what is this? S3 minus S2. Let you consider, it is another result, another equation 6. Do you understand this? This is what? S3 minus S2, b into c power n plus 1 multiplied by c power n minus 1 whole square divided by c minus 1. Though we have calculated S2 minus S1, we have also calculated S3 minus S2. Now we divide these two, that is 6 and 5. We divide these two equations. What you will get? S3 minus S2 by S2 minus S1. So it here c power n plus 1, here c. So c will get cancelled, c power n will be there. B will get cancelled. C power n minus 1 whole square by c power c minus 1. Here also, here also. So these two terms will get cancelled. Only the term is c power n. Therefore, by dividing these two equations, what are the equations? Equations 6 and 5. Equations 5 and 6, if you divide, these are two equations, then you will get S3 minus S2 divided by S2 minus S1 is equal to c power n. Simply we got this value. Therefore, which implies what you have to calculate? C. C is equal to S3 minus S2 divided by S2 minus S1 the whole power 1 by n. Whole power 1 by n. So this is the value of C we have obtained. And now we have two particular values. I am considering this is another equation 7. This is another equation 8. 8 is the value of C. 7 is the value of C power n. So I am not going to substitute all the values. So as if the C value, whenever we have a C power n, I substitute C power n only. That is the reason why I have considered two equations here. Now I substitute only c power n to calculate b. Now you say that I will tell you how to calculate the b. So this is what this value of c power n. If you substitute in s2 minus s1 equation, I write the value of equation which is there in equation 5. So therefore I am considering s2 minus s1 is nothing but s2 minus s1 is equal to bc into c power n minus 1 whole square divided by c minus 1. This is what the equation. In this equation, I am substituting only the value of c power n. That is, it is equivalent to b. I am keeping as it is the values b and c, and divided by c minus 1 I am taking here, and so that I am substituting c power n. C power n is this s3 minus s2 divided by s2 minus s1. Okay, that is c power n minus 1 whole square. Is it clear? So I have taken only in this, I have considered this is equation 5. I have considered the equation 5 and I have substituted the value of c power n only here. Only c power n value I have substituted here. Remaining values I kept as it is. b into c divided by c minus 1 as it is. Multiplied by c power n, the value is this s3 minus s2 by s2 minus s1 minus 1 whole square. Minus 1 whole square. So this is the value of s2 minus s1. So therefore now it's simplified. bc divided by c minus 1 into this, if you take common, that is LCM as s2 minus s1, then s3 minus s2 plus s1 divided by s2 minus s1 the whole square is equal to, now bc divided by c minus 1 into, this is s3 minus 2s2 minus s2 minus s2 2s2 plus s1 divided by s2 minus s1 the whole square. This is the value of s2 minus s1. Now what we have to calculate? We have to calculate the value of b. We have to calculate the value of b. So you have to take all the terms to the left hand side so that b is equal to, I am taking c minus 1 and c. Therefore it is c minus 1 by c. c by c minus 1, take the left hand side, c minus 1 by c multiplied by s2 minus s1 whole square. This is also s2 minus s1. Therefore s2 minus s1 whole cube divided by now s3 minus 2s2 plus s1 whole square. If you take this particular term to the left hand side, then it becomes in the denominator s3 minus 2s2 plus s1 the whole square. Clear? This is the value of the b. I am considering this is equation 9. This is value of b, but we have not written the value of c. What is the value of c? We have to substitute whenever the c value, it is s3 minus s2 by s2 minus s1 whole power 1 by n. We have to substitute here, that's all. The value whenever you calculate s3 minus s2 by s2 minus s1 whole power 1 by n, you have to substitute in the value of c. Okay. So therefore b is obtained. The b is obtained just by keeping the c here only by substituting c power n. This is the value c minus 1 by c into s2 minus s1 whole cube divided by s3 minus 2s2 plus s1 whole square. This is the value of b. So now we have obtained b and c. So now we have to obtain the value of a, for which I am considering equation 2. What is equation 2? I write here. That is the value of s1, partial sum s1. What is s1? na plus bc into c power n minus 1 divided by c minus 1. Again I substitute here only c power n and b. I don't substitute the value of c. If you observe, I don't substitute the value of c. C value is s3 minus s2 by s2 minus s1 whole power 1 by n. That is, we have to substitute whenever we have a C. So I'm not substituting the value of C. Keep concentrate in this particular point. Concentrate on this particular point that we are not substituting C. We are substituting C power n. Just for simplicity, that's all. So therefore, first I calculate A. In this particular term, you have to take left hand side. Therefore, NA is equal to S1 minus BC into C power n minus 1 divided by C minus 1. And therefore, A is equal to 1 by n into S1 minus BC into C power n minus 1 divided by C minus 1. Now, what I have to substitute? I have to substitute the values of B and C power n. Now I substitute is equal to, therefore A is equal to, I write here, yeah, A is equal to 1 by n multiplied by S1 minus BC. First of all, I substitute B. What is the value of B? C1 minus C, C minus 1 divided by C into S2 minus S1 whole cube divided by S3 minus 2S2 plus S1 whole square. Okay, that is the value of B. You refer equation 9. The value of B is this. Now, multiplied by C. You see, this is C minus 1. Therefore, C by C minus 1. I am writing here. And I am substituting now C power n. What did I say? I substitute the values of B and C power n, not C. Only C power n and B. What is C power n? That C power n is nothing but S3 minus S2 divided by S2 minus S1 minus 1. Clear? C power n is S3 minus S2 by S2 minus S1 minus 1. Now you see C will get cancelled. C minus 1 will get cancelled. So therefore, you see that's what the simplicity of not substituting C. So 1 by n multiplied by S1 minus, now we have to simplify these values. S2 minus S1 whole cube divided by S3 minus 2S2 plus S1 whole square into, if you take an LCM S2 minus S1, this becomes S3 minus S2 plus S1, that is S3 minus 2S2 plus S1, 2S2 plus S1. Now we say we can cancel S2 minus S1, one particular term. Here S2 minus S1 whole cube, S2 minus S1 we are cancelling. S3 minus 2S2 plus S1, this is also same. So therefore this is S3 minus 2S2 plus S1 whole square, hence it is, we can cancel one term. Therefore, now it is equivalent to be 1 by n multiplied by S1 minus, this is S2 minus S1 whole square divided by the only one term S3 minus 2S2 plus S1. By simplifying this, we will get the term, right? So therefore, it is equivalent to be, I do here, 1 by n multiplied by, if you take an LCM, S3 minus 2S2 plus S1, then now by multiplying S1 with this value, S1 S3 minus 2 S1 S2 plus S1 square, right? S1 into S1 square. Next, by doing the square here and then by substituting the values here, that is just to do the square, A minus B whole square, minus S2 square minus S1 square plus 2S1 S2, minus of minus, because right, plus 2S1 S2. Therefore, minus 2S1 S2 plus 2S1 S2 will get cancelled. Minus S1 square plus S1 square. So the final value for A is nothing but the final value, it is 1 by n multiplied by S1 minus S3 minus S2 square. S1 S3. S1 into S3 minus S2 square divided by S3 minus 2S2 plus S1. Right? This is the value of A. Let you consider equation 10. So, probably what I remember, the values of 8, 9 and 10. The values of 8, 9 and 10, which are the values of the parameters A, B and C, which gives you A, B and C. So, by the method of partial sums, we calculate S1, S2, S3 first, and then by using the partial sums S1, S2, S3, the values of A, B and C are going to be calculated in this way. See, this is what C in the equation 8. C is equal to S3 minus S2 by S2 minus S1 whole power 1 by n. And this is what B, equation 9. C minus 1 by C. What is C? C is nothing but S3 minus S2 by S2 minus S1 whole power 1 by n. Just now, equation 8. Refer equation 8. C minus 1 by C. P is equal to C minus 1 by C into S2 minus S1 whole cube by S3 minus 2S2 plus S1 whole square. This is what the value of B, this entire value. Now A is obtained here. A is equal to 1 by n into S1 minus S3 minus S2 square divided by S3 minus 2S1 plus S1. S3 minus 2S2 plus S1. So this is what the value of A. So A, B, C are the parameters is obtained, which gives you the best modified exponential curve. The yt is equal to A plus B into C power t in the time series data of a particular time series data. Hope you understand. This is what the method of partial sums of fitting the modified exponential curve. Thank you.